Hi students, welcome to Future Dr. Neet Academy for the problem solving session in NEET Physics. But today we are not going to solve the problem or not going to find a solution. Today is a questionnaire session. Problem questionnaire session. 7 questions will be given today, that is this session, and in next session we will solve the problem for these 7 questions. Topic chosen here is from chapter 9, Ray Optics and Optical Instruments. Let's move to first question. Question number 1. An object is placed on the principal axis of a concave mirror at a distance of 1.5 f. What is f? F is the focal length of the lens. The image will be at dash. Option A, minus 3 f. Option B, 1.5 f. C option, minus 1.5 f. Last option, 3 f. That is focal length. You want to find the image will be at image distance in terms of focal length. Let's move to question number 2. The critical angle for total internal reflection from a medium to vacuum is 45 degree. The velocity of light in that medium is dash. A option 1.5 into 10 power 8 meter per second. B option 3 by root 2 into 10 power 8 meter per second. C option root 2 into 10 power 8 meter per second. Last option 3 into 10 power 8 meter per second. So here you want to find the velocity of light in that medium with respect to velocity of light in that. Let's move to question number. In total internal reflection, when the angle of incidence is equal to the critical angle for the pair of media in contact, what will be the angle of refraction? Option A, 0 degree. Option B, equal to the angle of incidence. C option, 90 degree. Last option, 180 degree. Here you want to find the angle of refraction. Let's move to question number 4. A ray of light is incident at an angle of incidence I on one face of the angle of prism A, assumed to be small. Angle of prism is assumed to be small value and emerges normally from the opposite face. If the refractive index of the prism is mu, then the angle of incidence I is nearly equal to dash. A option, mu times of A. B option, mu by 2 times of A. C option, 1 by mu times of A. D option, 1 by 2 mu times of A. Let's move to question number 5. A transparent cube contains a small air bubble. Its apparent distance is 2 cm when seen through one face and 5 cm when seen through other face. If the refractive index of the material of the cube is 1.5, then the real length of the edge of the cube must be dash. A option 7 cm. B option 7.5 cm. C option 10.5 cm. Last option 14 by 3 cm. Let's move to question number 6. Sixth question. A beam of monochromatic light is refracted from vacuum into a medium of refractive index 1.5. The wavelength of refracted light will be dash. A option dependent on intensity of the refracted light. B option same. C option smaller. Last option larger. So you want to find the wavelength of the refracted light. Next question, last question, 7th question. A convex lens and a concave lens, each having same focal length of 25 cm, are put in contact to form a combination of lens. The power of diopter of the combination is dash. Option A, 25 diopter. B, 50 diopter. C, infinite. D, 0. Here you want to find the power of the lens of the combination in the unit diopter. Thank you. And in next session, we are going to find the solution of these 7 problems. Thank you. Thank you, students.